Hi guys, welcome to 2.2 on Indices. And if you're wondering what indices are all about, actually, in this chapter is pretty much just the application of the rules of indices. Okay, so to start us off, let's look at the laws of indices. And then I'm just going to give you some examples to study off. Okay, so a to the power of 0 is 1. So for example, 2 to the power of 0 is just 1. Another example, let's say 5 to the power of 0 is just 1. Okay, you can check this on your calculator. Okay, next one over here, a to the power of negative p is 1 over a to the power of p. So for example, 2 to the power of negative 5, for example, is just 1 over 2 to the power of 5. Okay, one more example. Let's say we have 4 to the power of negative 7. Okay, this is just, or this can also be written as 1 over 4 to the power of 7. Okay, next one. Let's say we have a to the power of 1 over p. So let's say we have 3 to the power of 1 quarter. Okay, this can be written as the root 4 of 3. Okay, take note that this number over here comes outside of the square root sign, and the number here comes inside of the square root sign. Okay, so one more example, something slightly tougher. Let's say we have 5 to the power of 2 over 7. Okay, take note that if I want to apply law number 4, I need to first identify my a, my p, and my q. So a is just 5. Okay, a is just 5. P in this case is 2. Q is 7. Okay, so this can be written as root, okay, since a is 5, I'm going to write my 5 here, and p, okay, comes outside, so p is 2, so I'm going to write my 2 over here, and finally q, which is 7 in this case, goes over here. Okay, so I know rule number 4 is a little bit tougher. Okay, so I shall give you one more example for rule number 4. Let's say I have 4 to the power of 5 over 6, for example. Okay, this can be written as, okay, once again, let's identify. So in this case, 4 is a, so 4 goes here. The root of p, and p is 5 in this case, so 5 goes here. And finally, 6 comes over here outside. Okay, so let's move on. Okay, let us carry on with the laws of indices. So over here, as you can see, I have a to the power of m times a to the power of n will give me a to the power of m plus n. So for common base, the powers will add up. So for example, x to the power of 2 plus, multiplied by x to the power of, multiplied by x to the power of 5, for example, will be equals to x to the power of 2 plus 5, which is x to the power of 7. Okay, so let's say I have x to the power of 5 divided by x squared, okay, over here. Okay, since we have a common base, the powers will subtract. So this will give me x to the power of 5 minus 2, which is just x cubed. Okay, moving on, next example. Let's say I have x squared to the power of 5. Okay, so x to the power of m in this case is 2, n is just 5, so it will be x to the power of 2 times 5, which is x to the power of 10. Okay, next example. If we have a common power but a different base, we can multiply them together. So let's say I have x to the power of 3 times y to the power of 3. This can be written as xy to the power of 3. Okay, so what if we have different base, common power, but a division sign? So for example, x cubed divided by y cubed can be written as x over y cubed. Okay, so that's all for laws of indices, and in the next few examples we will look at how to apply them. Okay, so I'll just leave the laws over on the right hand side of the screen, okay, because I know this is new to you. So what I will do, I will first evaluate, okay, what this complicated expression I see over here. So first and foremost, let us change 9 to a common base. So the base that I'll be using is base 3. Okay, so 3 1/3 times 3 power 0. Okay, times 9 is just 3 square, okay, to the power of 1/3, and 27 is actually 3 to the power of 3. okay, to 2/3. Okay, so at this moment, take note that 3 to the power of 0 is just 1, as you can see at in law number 1 over here. And then, okay, so this is just 1. And 3 square to the power of 1/3, you can apply this law over here. Okay, this law that you see over here. So this, it will just give me 3 to the power of 2 times 1/3, which is 2/3. Okay, same for what you see in the denominator. So 3 times 2/3 will give me 2. Okay. Okay, so now we have a common base. Okay, we have a common base, and 1 is, anything multiplied by 1 is itself, so 1 is not important anymore. And 1/3, okay, so 3 to the power of 1/3 times 3 to the power of 2/3 will just be 1/3 over here plus 2/3 over here. The law that I'm applying, okay, is this law you see over here. Okay, divided by 3 square, and let me just continue over here. 1/3 plus 2/3 is 1 whole, and 3 square over here. Okay, so last but not least, I will be applying this law you see over here. So a to the power of m divided by a to the power of n is a to the power of m minus n. So 3 to the power of 1 minus 2. This gives me 3 to the power of negative 1. And finally, applying this law you see over here, okay, I'll just get 1 over 3 to the power of 1, which is just 1/3. Okay, so that's all for example number 1.